Hello children, welcome back again. So here in this particular video we are going to learn regarding the advantages, limitations and also the modifications of Arrhenius theory. So previously we saw the Arrhenius theory regarding some concepts of strengths of acid bases, neutralization and also regarding acid and base definitions regarding the particular Arrhenius theory. So in this particular video we learn what are the advantages regarding Arrhenius theory and what are the limitations also regarding Arrhenius theory and also regarding their modifications. So these three concepts we are going to learn in this particular video. So it was a full video with a full length. Okay, here we go with the advantages of Arrhenius theory. Advantages means what are the sources of advantages of a particular Arrhenius theory to what this particular theory got with the popular thing. Okay. Now, let's see what is the first point regarding advantages of Arrhenius theory. Here we go. The common reaction in neutralization. In the previous video we saw discussed regarding neutralization, no? Yeah, in that particular thing. The common reaction in neutralization is the reaction between hydrogen and hydroxyl ions. So according to Arrhenius, the neutralization is the reaction between H plus ions of an acid and OH minus ions of a base, yes, to give rise to a undissociated water. So H plus is represented as H plus, which is hydrogen ions, and OH minus, it is a hydroxyl ions. So these both are given out with the particular of neutralization reaction concept, yes. So these two are mainly included regarding when these both react, they gives rise to a undissociated water. So that is nothing but a common reaction for a neutralization reaction. So the reaction is between them. What is that? H plus ions of an acid and OH minus of an ions of a base. Okay. So next, this lends a strong support to Arrhenius theory. So this particular statement regarding the Arrhenius theory, according to him, this leads to a strong support for this particular theory. Because why? He gave the names of acids and base definitions regarding H plus and OH minus respectively. So based on that only, he derived neutralization concept based on a particular H plus ions and OH minus ions with examples too. So that leads to a strong support for the Arrhenius theory. Okay. And next, as the definitions are simple, the theory is popularly used even today because the theory is very simple. No? Acid have separate definition, base separate definition, based upon the strengths of acids, strong acids definition, weak acids, strong bases, weak acids respectively, and based upon that neutralization, everything is given and it is very simple to understand and learn. That's the reason it's popular even today. Theory of Arrhenius is very popular even today because of that reason. So these two are the advantages of Arrhenius theory. Okay, this is all about that, and let's move to the limitations of Arrhenius theory. So where are the drawbacks of Arrhenius theory? So limitations are also known as drawbacks. What is that? Drawbacks. So there are some disadvantages, we can say drawbacks or limitations regarding Arrhenius theory. We'll see what is that. First one is all about failure in non-aqueous medium. Remember what is that? Failure in non-aqueous medium. Now, what is the failure in non-aqueous medium telling us regarding the limitation of Arrhenius theory? Okay, let's see what's that. This concept can be applied only to aqueous solutions. Children, according to Arrhenius theory, the concept is completely obtained and applied to only aqueous solution. Because why? We wrote the word AQ with the bracket, you remember? Bracket, small a, small u, the parenthesis, open parenthesis, close parenthesis, AQ, yes. So there it is representing which solution? Aqueous solution. But there is no representation, there is no mentioning, no applications of non-aqueous medium is telling us, okay, the failure in non-aqueous medium. This concept can be applied only to which solutions? Aqueous solutions, okay, of acids and bases, and fails for non-aqueous solutions of acids and bases. So the first particular disadvantage or the drawback or else the limitation we can see regarding Arrhenius theory. Okay, so for example, let's take HCl. I discussed HCl, all these things. HCl is dissolved in water. Okay. It acts as an acid. Yes. HCl is dissolving in water to produce H plus ions. It's acting as an acid. Yes. Okay. But when it is dissolved in benzene, what is benzene? Benzene is represented in the chemical formula C6H6. 6 atoms of carbon, 6 atoms of hydrogen. C6H6. So, if HCl is dissolved in water, it produces H plus, which means water is a aqua solution. So, it gives happily liberating H plus ions. Yes or no, where it is? Yeah, it liberates which ions? In what it liberates? H plus ions in the water, because HCl is acting as an acid in aqueous solution. And when it is dissolving in benzene, it is not furnishing H plus ions, nor showing any acidic property. And that's the problem, and that's the main disadvantage according to Arrhenius theory in the failure of non-aqueous medium. So, in particular benzene, HCl is not acting as an acid. Why? Because it is not furnishing H plus ions, and also it is not giving any acidic properties. That's the reason in non-aqueous solutions such as benzene, it is not dissolving, it is not giving any furnishing H plus ions and acidic properties, right? So, in that case, it is not showing exact theory of particular Arrhenius one regarding the non-aqueous medium. So, it's definitely a drawback, definitely a limitation we can say regarding failure in non-aqueous medium especially, okay. In aqueous medium, simply completely happily dissolving, okay, gives rise to liberation of H plus ions. But in non-aqueous only, it is giving a problem, such as benzene, okay. Remember that, benzene, okay. Okay, now second one, the second disadvantage or else limitation or drawback regarding Arrhenius theory is absence of hydrogen ions but still acids. Children, Arrhenius said to the acid, particular definition, it should contain hydrogen atom and it should give H plus ion. Particular acid, it should have these 2 points. What is the first point? Key point is it should contain hydrogen atom and acid should liberate hydrogen ion, H plus ions. Yes, but here there are some acids which doesn't contain hydrogen ion and it also doesn't contain hydrogen atom, but it is an acid. We'll see what is that. Second one, second failure is absence of hydrogen ion but still acids. There are some acids also considering as acid, but that is not included in the Arrhenius theory, because according to Arrhenius, it should definitely contain hydrogen atom and also it should liberate H plus ions, right? But there are some acids, okay, which doesn't contain both. We'll see what is that and how it is included here, okay. Here, acidic nature of SO2, SO3, BF3 and P2O5 cannot be explained on the basis of this theory, as they do not have H plus ions on their own. Children, these 4, what are these 4? SO2, SO3, BF3 and P2O5, these 4 are having acidic natures. Okay, they 4 are having acidic natures here, acidic natures, but they do not contain any H atom, which means hydrogen atom. And if they don't contain H atom, what will happen? It will not liberate into H plus ions in the aqueous solution, okay. But these 4 are generally having acidic natures, but they do not have hydrogen atom and also they do not give any H plus ions in aqueous solution by their own. So, how these 4 are regarded as acids according to Arrhenius theory? Not required, not there, no. So, the theory is failed to tell these 4 particular acids and the behavior regarding the hydrogen atom and liberation of H plus ions. Okay, what we call all the 4? I'll write here for you. SO3, first one is SO2, no? SO2 is named as sulfur dioxide. What is SO2, children? Sulfur dioxide, okay. Now, next example, SO3 is sulfur. I told you in the previous videos, children, SO2, S means sulfur, element sulfur, and O2 means, O means oxygen, so it is O2 in the complex form, O2 means di, very good, dioxide. Now, here, S means sulfur, O3, how many oxygens? 3 oxygens, which means it is a trioxide, very good, trioxide. Now, what else we have? BF3, no? BF3, boron trifluoride, boron trifluoride. Okay, B means boron, F3 means trifluoride. Okay children, now we have fourth one is P2O5. What is that? P2O5. It is represented as 2, no? Phosphorus is P, 2 phosphorus, no? So we have read diphosphorus. Diphosphorus. How many oxygens? 5. 5 means penta. Very good. Pentaoxide. What is this? Pentoxide. Fine. This is the name for the given the 4. What is that? The previous page we have here. Okay. Absence of hydrogen ion but still acids. What are the 4? Sulfur dioxide, sulfur trioxide, boron trifluoride and phosphorus, diphosphorus pentoxide. Okay. So these 4 are having acidic nature but not according to Arrhenius. These 4 are not given the points regarding the acidic natures and the answers are given them under the particular Arrhenius theory. Okay. So these 4 are having acidic natures. These 4 are having acidic natures but these 4 are not included as acids regarding Arrhenius theory. Why? Because those 4 doesn't have H atom. So it doesn't have any H atom in the particular molecular formula. How can they give rise to H plus ions in the particular acids? Aqueous solutions. Can't, no? So these 4 are not having any, do not have an H plus ions. So on their own, this theory is failed regarding the absence of H atom, and because those 4 are acidic natures only. Those 4 are acids only, but because they have acidic natures. Okay, but it is not considered as acid regarding the particular Arrhenius theory. Okay, so this the limitations of the second, that is limitations regarding the Arrhenius theory: absence of hydrogen ions, but still these are acids. Okay, now the third limitation regarding the particular Arrhenius theory is what? Let's see. Absence of hydroxyl ions but still bases, but still a base. Previously there is no H atom and now there is no OH representation. OH group is not there, it seems. Okay, but it is a base, it seems. But according to Arrhenius, it should have a OH group, right? It should have a OH group. Yes or no? But here Arrhenius theory should have it as a hydrogen atom. But those 2 are missing. Yes or no? Those 2 are missing. That's the reason that is failed. Okay. Basic nature of compounds like ammonia. What is that? Ammonia formula NH3 not having hydroxyl ions cannot be explained by this theory, because that particular ammonia NH3 is not having any OH group. If it is not having OH group, how can it give rise to OH minus ions, which means the hydroxyl ions in aqueous solution? This is also failed to explain regarding the Arrhenius theory. Okay children, so these 3 are the limitations of Arrhenius theory. And what are these 3? Once again, failure in non-aqueous medium, and next absence of hydrogen ions but still are acids. Next, absence of hydroxyl ions but still a base. So these 3 are the limitations regarding the Arrhenius theory. And next concept is all about modifications. There are some modifications regarding Arrhenius theory. We will see what are the modifications. Okay, here we go with the modifications. Yes, modification of Arrhenius theory. With a few modifications, Arrhenius theory can be made applicable not only to aqueous solution but also to the non-aqueous medium. Okay, that's the important point. With a few modifications, Arrhenius theory can be made applicable not only to aqueous solution, which means AQ, bracket AQ is there, no? Aqueous solutions, which is water, liquid content children. Okay, but also to non-aqueous solutions. What is the modification over here? Not only to the aqueous solutions but also to the non-aqueous solution. But before it is not there, no? Non-aqueous is not there, that is limitation, right? But after modifications, they added non-aqueous mediums are also represented in the particular modification in Arrhenius theory. Okay, and all polar solvents undergo ionization to some extent. producing positive and negative ions. Polar solvents and non-polar solvents are having different concepts, children. Here it is talking about polar solvents. All polar solvents undergoing ionization to some extent, producing positive and negative ions respectively, and water contains to a small extent equal number of H plus and OH minus ions. We know what is water molecule? Water molecule is represented H2O. Very good. So this water contains to a small extent equal number of H plus ions and as well as OH minus ion. Yes, so here it is represented. No, previous equation told you. Yeah, H2O gives rise to H plus plus OH minus. Before it is written as reverse. H plus plus OH minus gives rise to H2O. No, it is given like this, reverse. That's it. Okay. So here it is giving water contains to a small extent of equal number H plus 1. OH minus is also there 1 because it is having only one molecule H2O. 1, 2, H's are there, 1, 2 here and O, 1. It is represented like that, okay. And after that what happens? The modification regarding that. The small conductance of water is attributed to these ions. So somewhat water molecule is added, the small conductance of water is added. What happens? Double. One more H2O is added, okay. However, these ions get hydrated and the above equilibrium should be written as. For this particular equation, children, if they add one more molecule of the small conductance of water, what happens? It gives rise to same, it will come same H plus and OH minus. No, because it is having 4 hydrogens, 2 over here, 2 over. How many hydrogens? 4. How many oxygens? O and O. 2 oxygens. It will balance, no? We can't balance over here. So what we will do, we will represent like this. H3O plus, which is aqueous solution, and OH minus in the aqueous solution. Okay, I will write here the names of this. H3O plus is named as hydronium ion. Which ion? Hydronium ion. H plus is hydrogen ion. Very good. Hydrogen ion. H3O plus is hydronium ion. Okay. Now what about OH minus? OH minus is hydroxyl ion. Here also it is given OH minus, hydroxyl ion. But if you observe, these two are given in aqueous solution because why 2 molecules of water is taken, right? Okay. This is the reason where we will just have a small conductance of water in particular equation, okay, in the above equation. This is the representation. Before, 1 molecule of water gives rise to H plus and OH minus, and here 2 molecules of water gives rise to hydronium ion and hydroxyl ion, respective aqueous solution, and later the modification is extending with that of substance which increase in the aqueous solution H2O plus concentration behave as acids. So what we are doing here, we are adding some more water to it, and what happens? We observe the liberation of H3O plus concentration. What is that? Hydronium ions. What is represented? Acids only, no? Okay. So H3O plus concentrations are behaving as acids, while those which increase OH minus concentration in aqueous solution behaves as a base. Now clear? So after adding a small conductance of water, if they give more concentration of H3O plus, those are acids. And if not, if they give OH minus ions more, those are regarded as behaving as a base. So that particular substance which increase in aqueous solution of H3O plus, those are named as acids, and which increase OH minus ions are named as bases. So by that they gave the regarding the definitions of SO3, SO2, P2O5, BF3, all these things, okay. And what happens here? See, CO2, SO2, SO3, namely carbon dioxide, yes, sulfur dioxide, sulfur trioxide behave as acids in water. Because why? Because the substance is giving H3O plus ions. That's the reason we are adding water molecules, 2 water molecules for that particular acids to give more liberation of H3O plus to get it is behaving as a acid. What is that? CO2 and SO3 and SO2 also, okay. Okay, fine. Did you understand now? CO2, SO2, SO3 behave as acids in water as they increase the H3O plus concentration in the aqueous solution. Okay. So what is CO2 over there? I'll write the name. CO2 means carbon dioxide. CO2 means carbon dioxide upon acting with two molecules of water gives rise to hydronium ion. What is this ion name? Hydronium ion. And for this carbon dioxide we get which ion, you know? We get carbonate ion. Which ion? What is this? Hydrogen. Hydrogen. H means hydrogen, no? CO3 means carbonate. Hydrogen carbonate ion, or it is also called as bicarbonate ion. Bicarbonate ion. Okay, did you understand now, children? See, first we are taking CO2 and for that we are adding two molecules of water. So it is giving H3O plus ions more, but there is no liberation of OH minus here. Did you see? Did you observe? Any OH minus is there? No. So there is only liberation of H3O plus, which means it is a hydronium ion. So that condition, if it is giving H3O plus concentration in the aqueous solution, and that particular substance is regarded as acids. Okay, did you observe? And that is given here, the example. So CO2 and SO3 upon reacting with two molecules of water giving rise to high concentrations of H2O plus, so those are regarded as acids. If it is OH minus, that is base. Okay. Before exceptions are there, no, children. CO2, here we will say CO2 also. See, CO2 means carbon dioxide. Okay. So all these we all know, these substances are not having hydrogen atom, hence they will not liberate hydrogen ion in the aqueous solution. We told you know. Yes. So in that case, according to Arrhenius, these are having some drawbacks. Okay. But the modification is like this, where they are adding two molecules of water. Okay. And if that, the small conductance of that particular thing, if it liberates more H2O plus, it is an acid, and if it liberates OH means it is a base. That is given clarity regarding the modification of acid and base. Okay. Now CO2 and SO3 are definitely a acid. Not only these are also definitely a acids, because by upon acting with two molecules of water, they give H2O plus ions respectively. Okay. And here SO3 is named as, what is SO3? Come on. Very good. Sulfur trioxide upon reacting with two molecules of water gives rise to, the respective hydronium ion. And which ion is this? HSO4 minus. Come on, tell me. Hydrogen sulfate ion or bisulfate ion. Bisulfate ion. Okay, clear no? This is all about the modification in the acids which do not have H atom in the particular formula. Okay, clear. Now, regarding next one, here if you see, is here up to acids and now different. NH3 ammonia, CaO calcium oxide, Na2CO3 sodium carbonate behave as bases. So these three in the previous particular topic they include only ammonia, but here they have given two more examples, namely calcium oxide and Na2CO3. What is that? Sodium carbonate behave as bases in water as they increase OH minus ions concentration in the aqueous solution. Okay. So whatever liberating OH minus ion concentration in the particular given equation, that is given as a base, and whatever giving H2O plus concentration hydronium ion are given as base acids regarding particular modification in the Arrhenius theory. Okay. Here the name of NH3 is NH3. I'll let the names over here for children for you. These all, should I'll write here. Okay, just a second. Okay, so the given NH3, I'll do different color. Yeah. Okay, so NH3 ammonia. Next CaO, this is calcium oxide, and given other one is Na2CO3, this is sodium carbonate, okay. So these are given bases regarding the examples of this particular what? Bases and acid sections, okay. So NH3 is what? Ammonia, and to this if I add two molecules, okay, one molecule here, one molecule of water, what happens if it liberates? NH4 plus in aqueous solution also, OH minus, very important is OH minus, okay. So it liberating NH4 plus, which means it is a ammonium ion. Which ion, children? Ammonium ion. And what is this? Hydroxyl ion. OH minus is named as hydroxyl ion, okay. Yeah. So in the first example, ammonia is dissolving in water to give rise to ammonium ion aqueous solution and hydroxyl ion AQ aqueous solution, representation OH minus, okay. This is the first example regarding the liberation of OH concentration, which is regarded as a base. Very good. NH3 is a base, okay. Now sodium carbonate, what is this? Sodium carbonate upon reacting with water gives rise to sodium ion, two molecules of sodium ion in aqueous solution, okay. Now here H3O minus, what is this? Hydrogen carbonate ion, or also called as bicarbonate ion, very good. And OH minus, it is a hydroxyl ion respectively in aqueous solution. So all these are aqueous, okay. This two also aqueous. Please observe, in aqueous solution is giving rise to the particular OH minus concentration. So these are regarded as bases. What are three? What are two? NH3 and sodium ion, and also this is also CaO is also regarded as base, okay, because why? It is also having a reaction regarding CaO plus water gives rise to the particular calcium hydroxide, and also OH minus ions are given now regarding like that. So if we consider like that, there is a the clearance of the modification of acids and bases, where all these are considered as acids in the particular modification Arrhenius theory accordingly, and these three are regarded as bases according to modification of Arrhenius theory, okay. But regarding of a limitation, Arrhenius theory limitations, these are not having any H atom in the particular molecular formula, so they can't give rise to H plus ion. Yes or no? And what about these three? These three doesn't have any OH group, which is it is known as yes. So it is not giving rise to OH minus ion respectively. But if there is the addition of water to it, for this acid addition of two water molecules and this addition of water molecule, one water molecule, they give rise to H3O plus, okay, hydronium ion. That concentration is regarded as, but all these are acids, and for bases, if they liberate OH minus ion, they give rise to bases. So this is all about the particular concept of acids and bases regarding Arrhenius theory and also its modifications, okay. So these are considered as the acids and bases after the modifications of Arrhenius theory, but before that there is no special recognition and representation of particular acids, no. That's the reason they gave here like this, okay. After the explanation, it is written like this. Clear, no children? Up to here clear, no? Okay. So this is all about the examples and the acids and bases definitions and the given H3O plus concentration is a particular acids and OH minus it is a base. So this is all about the particular thing. And one more. Other polar solvents may also be regarded as undergoing dissociation to some extent. So we included here NH3 plus H2O gives rise to ammonium ion in aqueous solution and giving rise to plus 1. What is that? Hydroxyl ion. And here what is that telling? They are telling other aqueous solutions in the particular polar solvents, they may be regarded also by the undergoing dissociation to some extent. Okay, dissociation in the sense, yeah, liberating, the dissociation, completely dissociating. Okay, and to some extent, and those liquid ammonia behaves as solvent due to the particular falling equilibrium. We'll see what is that. We know ammonia, NH3, yes, that is what. So if we take two molecules of ammonia, ammonia plus ammonia, what happens? You know, it gives rise to ammonium ion and one more. What is that? We'll see. What is that? NH2. NH3 is, you know, what is this? NH3 means? NH3 means ammonia. Ammonia. NH4 means? Sorry, NH4 plus means which ion? Ammonium ion. Very good. Ammonium ion. What about NH2 minus? NH2 minus is named as amide ion or azenide ion, or we can say azenide. Okay. So here if we intake NH3 plus NH3, two molecules of ammonia, you know what it happens? It gives rise to ammonium ion, M is there, okay, ammonium ion plus amide ion, that is also called as azenide. Okay, the formula is NH4 minus. Here it is NH4 plus is cation, positive radical, and NH2 minus is a anion, which is a negative radical. Okay, this is a given equation for the ammonia, the liquid ammonia. Okay, and substances such as NH4Cl, what is NH4Cl? NH4Cl is a ammonium chloride. Right here, ammonium. I'll do the yellow color, children. Ammonium chloride. What is an ammonium chloride formula? NH4Cl. Substances such as NH4Cl, ammonium chloride, which increase NH4 plus, which means what? Ammonium ion concentration in liquid ammonia. In which one? In liquid ammonia, it behaves as acids. Okay. So in that case also we can regard it with the polar solvents, also we can derive acids and bases, children. Okay, not about only H2O plus ions and OH minus ions, we also have these things. Okay, if it is having liberation of NH4 plus ions, ammonium ions, those are behaving as acids. Similarly, substances like NaH2, what is NaH2? NaH2 means, I'll write it down, sodium amide. What is this, children? Sodium amide. Similarly, like sodium amide, which increases amide ion concentration, very good as NH2, amide ion concentration, those behaves as a basis in ammonium solution. So we have two equations over here, children. Remember carefully, if there is a liberation of more, well, taking two molecules of water, if there is a liberation of H2O plus concentration ions, those are called as acids. If it is taken as OH minus ions, it is given as bases. Similarly, if we take liquid ammonia, NH3 plus NH3, if we take two molecules of liquid ammonia, and to that if there is liberation of ammonium ion, the concentration particular things, those substances are called as acids. And if it liberates NH2 minus, which means it is a amide ion or azenide, those substances are regarded as bases regarding with the polar solvents. Okay, for that, like this, we will just give the modification regarding acid base regarding the particular concept regarding to Arrhenius theory. Okay, this is all about that, children. Hope you understood. Okay, this is special, you know, what we say, the modification regarding with the ammonia. Okay, so whatever if you see NH4 plus liberating concentration, that is given as acids, behaves as acids. And if you see the liberation of NH2 minus, which means amide ion, that is written as a base, okay, because minus that one, bases, no, because bases have OH minus ion and acids have H plus, no. So cations are behaving as acids and anions are behaving as bases. This is all about the concept regarding Arrhenius theory. So the modifications before, limitations and before, advantages, all these are the particular regarding the concept regarding to Arrhenius theory of acids and bases. So hope you really understood this particular concept, children. And the scientist behind is this, what, who is him? Who is it? Who is the scientist behind it? Very good. Arrhenius theory is given by Svante Arrhenius, and its all definitions and all given in the year 1884. Okay, this is all about the concept Arrhenius theory, and hence in the session here. Thank you.